Please open in your learning workbook to page 147. We're now going to solve an example problem. Graph the parabola in standard form, y equals x squared minus 4x plus 9. The first thing that we want to notice about this parabola is it's missing those parentheses like the vertex form has. The vertex form looks like this. This does not have that same structure. There's no parentheses. So this must be the standard form. Y equals ax squared plus bx plus c. This is very important because it tells us that we're not going to use a, h, and k in this problem. We're going to use a, b, and c instead. Okay, let's find the values of a, b, and c. Here we go. First of all, the coefficient of x squared is 1. So this is a 1x squared. So that tells me that a for this problem equals 1. B for this problem equals -4. C for this problem equals +9. Now, remember, the vertex is h and k, and we don't have h or k for this problem, but what we do have is a formula. The x coordinate of the vertex is equal to opposite b over 2a, which for this problem is opposite -4 over 2 times 1, which is 4 over 2, which is 2. So our vertex x is 2. Now we just have to plug in to find what is y. Well, we know that y equals x squared minus 4x plus 9. If x equals 2, then we get 2 squared minus 4 times 2 plus 9. Y equals 4 minus 8 plus 9. 4 minus 8 is -4 plus 9 is 5. So that tells me that my vertex for this particular problem has coordinates 2, 5. Once you determine your vertex, the rest of the problem is just like the previous learning objective. Let's create our XY table. Here we go. X and Y. 5 rows. Vertex goes in the middle. Okay, what x value should we use for this problem? We're going to count up by ones, and we're going to count down by ones. All right, now we're going to plug in each value of x. If x equals 0, then, plugging into our equation, y equals 0 squared minus 4 times 0 plus 9. That's 0 minus 0 plus 9, which is 9. Now we should get the same value when we plug in 4. Let's do it just to make sure that we're correct and we haven't made any mistakes. If x equals 4, then y equals 4 squared minus 4 times 4 plus 9. 16 minus 16 plus 9. 16 minus 16 is 0 plus 9 is 9. And indeed we get the same result. All right, now let's try 1 and 3. If x equals 1, then y equals 1 squared minus 4 times 1 plus 9, which is 1 minus 4 plus 9. 1 minus 4 is -3, plus 9 is 6. All right, and the only one left is 3. If x equals 3, then y equals 3 squared minus 4 times 3 plus 9, 9 minus 12 plus 9. 9 minus 12 is negative 3 plus 9 is 6. Okay, so by doing all 4 of these calculations, it allows us to double check our work. These should match and these should match, and indeed they do. That gives me confidence that my points are probably correct. All right, now we're ready to create our graph. I see no negatives in my XY chart, which means I only need quadrant 1. My y's go all the way up to 9, so I'll go all the way up to 10. I'm going to start by making a dashed square to establish the location of 1 on the x and 1 on the y. I'll erase the corners of my dashed square. Okay, now I can plot my points. 0, 9. That's the y-intercept. 1, 6. 2, 5. 3, 6. 4, 9. And we connect them to make the nice parabola shape that we're used to seeing. Couple of observations before we call this problem done. The y-intercept in this problem was 9, which matches the number we have here. This characteristic is only true for standard form. When your parabola is in standard form, then c, the number at the end, tells you your y-intercept. And, as before, a is positive and our parabola opens up. Okay, we could draw our axis of symmetry and identify its equation, but I've done that for a couple of examples, and for now I'm going to leave that out. All right, that concludes this example problem from page 147 of the Learning Workbook.